First off, good afternoon. I am Jason Thomas, Project Engineer with America Makes, and your host for today's America Makes webinar series. A little background on the TRX webinar series before I introduce our speaker. As America Makes continues its mission to expand and accelerate the footprint of additive manufacturing and 3D printing, this medium called the America Makes Technical Review and Exchange webinar series was created. By creating this platform, it allows the additive manufacturing and 3D printing community to come together and share knowledge and experience with a broader community. If you or your team are interested in presenting during the TRX webinar series, there will be a link to complete the request form at the end of our series today, or you can contact the America Makes Membership Director, Tiffany Westbay, directly. A few important notes before we kick off the series. At the end of the presentation, there will be an opportunity for a brief question and answer session. If during the presentation you have a question, please submit it in the Q&A space on your WebEx screen, and we will ask it during the Q&A session. We will do our best to get all the questions answered. Today's webinar is on protecting manufacturing IP and digital supply chains. Additive manufacturing disrupts the traditional manufacturing process by allowing for on-demand, on-site creation of parts and enabling a decentralized supply chain in which design and manufacturing are not necessarily co-located. This creates a digital flow of information from design file to finished product known as the digital thread. Vulnerabilities in the transmission of data may leave companies and government organizations open to cybersecurity attacks, resulting in loss of revenue from intellectual property theft, or safety and national security risks from counterfeit or maliciously modified parts. This presentation will discuss how digital distribution of information can be authenticated, transported, and recorded, leading to a safer digital supply chain. Without further ado, it is my pleasure to introduce Joe Inkenbrandt from Identify 3D. Joe Inkenbrandt is the CEO and co-founder of Identify 3D, a software company dedicated to protecting digital integrity from conception to manufacturing. A technology enthusiast, he has a broad professional background with years of experience in hardware and software engineering, security protocols, intellectual property licensing, and business development. His vision is to take concepts and methods of digital content management in mature industries and adapt them to the digital manufacturing world. Joe holds a BS in computers engineering from Purdue University and an MBA from the Haas School of Business at UC Berkeley. All right, Joe, I'll turn it over to you and your team now.
All right, thanks, Jason. So yeah, as Jason said, my name's Joe Inkenbrandt. I'm the co-founder and CEO of Identify 3D. We design and build products directly in this space. So our goal is through software to enable digital manufacturing. And one of our big value propositions is security. And so today we're going to talk about a little bit about what when we look at and work with our customers. The first thing we do is we want to do an evaluation. We'll talk a little bit about that and how we do security and how we approach it. Not only in this industry, but I'm going to show how we brought in other learnings from other industries. So the first thing we're going to do is we're going to talk about what is security, because it means something completely different to everybody else. So let's define exactly what we're talking about and kind of how we approach it. And then once we've figured out what security is and we've kind of got a good definition, we're going to build a structured approach to secure something. And so that's kind of how the presentation will go today. And so the first thing we're going to talk about is security and what is it? And so if I had everybody on this call going in line and I asked them point blank, what is security? I would get a ton of different answers. So to some people, it's counterfeiting parts. So somebody's stolen my IP and they're making something that's mine. It has my brand name on it and I'm worried about it. To other people, it's somebody's going to log on and attack servers and they're going to steal all of my intellectual property or just all of my data online and then sell it on the dark web. Other people are worried about, hey, I'm going to send something to a manufacturer and that manufacturer is going to manufacture 5 to fill the order that I've put out, and then they're going to manufacture 5 more and sell them off the back of a truck. And so some people are worried about that. Others are worried, and this is typically when we work with our DoD customers, worried about malicious modification. So somebody coming in and modifying my IP, and in such a way that, in this example, somebody came in and modified a propeller on a drone so that from the exterior it was invisible, that the modification had been made, but once you flew it, it lasted just long enough for the drone to get a proper height, and then the blade came apart. And then finally, some people are worried about ordering systems being hacked. So then ordering systems can be sent out, and pieces and parts can be sent all over the place. And so with that kind of broad definition, and there's 1,000 more of what just in general security could be, then you get, without that, the first thing you have to do is define what is the problem that you're trying to address. So a definition of security being that we adhere to at Identify 3D is it's a list of steps to reduce or eliminate threats to a system. So a threat could be a malicious operator or a hacker or whatnot, but we have to figure out what the threats are, and then we want to reduce or eliminate them. So that's what kind of security is. And when you start thinking about it, that respect, then threats might not just be what you were thinking about typically in a security, in the covert or what the movies show about security. It could be even more things. So what is the difference between an operator that accidentally makes an error when manufacturing a part versus somebody who's maliciously doing it? So now all of a sudden, security can actually start moving into, well, what are my QA risks? That can, not only are we preventing people from doing things incorrectly, but now maybe we're making sure that they make it in an ITAR or they make it in a correct way. So now security becomes a lot more broad, and it can move into things like operator error, information, and then even traceability. How do I know that maybe I don't want GE doesn't want customers to know how many rocket nozzles they made last year or what the yield rates were on them. And so all of a sudden, all of this becomes, the traceability aspect just becomes a different Now that we've kind of figured out what security is, how do you secure it? So again, if I asked everybody on this call how to do it, some people would say, well, we just need to put file protection in, and we need to encrypt our files. Others would say we need to add firewalls and keep the hackers out. Others would say we could put physical security measures, and we just need to lock our machines down and use physical locks. Or we're going to have somebody watch our people, and so now we can put auditors in place. Or finally, and this is one we get all the time, just add blockchain, that'll secure it. And so this is, again, there's a lot of misconceptions, and the solutions are out there. But what we have to do is we have to actually intelligently do it. So going back to our original definition is security is addressing threats in the system. So we have to figure out what threat are you trying to address. And that becomes really interesting, because if anybody ever tries to tell you that they have a solution that perfectly secures or locks down something, they're selling snake oil. There is no way to perfectly to defend against every attack in the world. It's not possible. And so when you secure something, you have to list what are the threats that I am worried about, and then you have to address those threats. So as the saying goes, the first step to finding a solution is you have to define the problem. And so what we do at Identify 3D is we use a framework, exactly that. And frameworks are used in several different industries. So OSHA has several frameworks for identifying workplace hazards. I'm sure many people on the call are known about that. In business negotiations, when I went to business school, we learned about, you can go in, anybody can negotiate, but you learn negotiating frameworks such as BATNAs and whatnot. And all of a sudden your negotiation results go way up, because you're now using a framework to increase the process. And then securing your network has one as well. It's called a SANS methodology, and it's in kind of an industry standardized way. And so at Identify 3D, we use something similar and mostly the SANS, but we've added some things to it and simplified it in other ways, specifically for manufacturing. But at a high level, our framework works like this. Build a model of what we're trying to secure. So what, and the thing about this is to understand is that model's ever perfect. A good economist will tell you that no model's perfect, but is it useful? So we need to build the model as detailed as possible so that it's still useful, but also we need to not worry about making it so precise that we spend all of our time building the model. So we're going to build a model, and then we're going to start poking holes on it. We're going to list what are the concerns and threats. Are we worried about operators? Are we worried about network infrastructure? Are we worried about what's being sold off the back of a truck? We're going to go through and we're going to list all of those. And then we're going to go through those threats, and we're going to rate them on the impact of how big of a problem if this happens, and then what's the likelihood of this happening. Because those are independent accesses, but between those two broad categories, we can actually determine, is this a threat we need to address, or how much do we need to use to address it? And we'll talk more about how that fits into the threat framework here in a moment. And then finally, for all of the threats that we are going to address, we need to list what are the mitigation steps, what are we going to do to address it, and then we're going to build solutions to address that. So we're going to start off and we're going to build a model. So this is a distributed manufacturing model. And so what the challenge here that we've just added is we've at the top, you can see we engineer almost all parts are engineered. Then the engineering works very closely with manufacturing. You go into a physical distribution, a physical storage, and then a physical distribution stage. So that's kind of the top. At the bottom, what we want to go to with the digital is you want to engineer, then you want to have a digital distribution where now the part will stay in its digital format for months or even years. And we're going to time shift how long it stays between engineering and manufacturing, as well as we're going to location shift it, right? So now might manufacture it on site, or we might manufacture it at a regional hub where we would normally just store the part. And so we time and location shifted manufacturing away from engineering, and we backfilled that with a digital infrastructure. And so that's kind of the problem that we're addressing here. And so you have this kind of digital life where all of a sudden you have to worry, in this case, specifically about your IP. So now that you have that digital life, you have problems like if somebody steals that digital recipe, there's a copyright problem. Now all of a sudden somebody is stealing it, or there's a compliance problem. How do I know they're going to make it in an authorized facility? There's a traceability problem because now it's being manufactured at a dozen sites over 3 years. So what's my yield rates? Do I need to re-engineer it? How do I make sure my operators aren't making mistakes or walking off with my parts? Or how do I make sure that the QA is done properly? And then finally, how do I make sure that the parts that are manufactured the correct way, that my customers know that if they have my logo on it, that it was made the way I wanted to and it's not a counterfeit part? And so all of a sudden, just because of this time and location shift and this added digital distribution, all the great benefits are there, but now there's additional problems caused. Let's kind of take the model to the next level. So in engineering, in a digital world, you're using CAM and PLM. In additive specifically, there's a good chance you're using Materialize, and then you might be using a PLM system to store your digital manufacturing assets, your technical data packages, whatnot, in your PLM system. So that's your engineering. In your digital distribution world now, you're going to get an ERP system that's going to get an order in from a customer. And now instead of going to a physical warehouse or looking up where it's going to look up in a digital warehouse and say, okay, instead of finding it on a physical shelf, it's going to find it on a digital shelf. And it's going to the digital warehouse is going to assign the order to a manufacturer that's probably running an MES system. And then somebody's going to come into that MES system and assign it to a specific printer. And then finally, the last kind of digital part is in a perfect world, the printer, in this case, an EOS printer, is going to then spit out a bunch of data that's going to talk about the metrology and what happened in the manufacturer, as well as what the operator in a qualified setting and what materials were used and whatnot. And all that's going to be fed back into an analytics platform so that it can be fed back upstream. And so we now have this kind of we have digital aspects in each of these these spaces. So now, so this is kind of our model, and this is kind of what we're going to start poking holes in. So then we're going to now apply it, the next step of our evaluation framework, which is we're going to start finding and rating the threats. So this is an IP analysis. So we're worried about somebody actually stealing the CAM file. So this is the G code or the job file that would normally go on an EOS printer in this case, possibly the SLI file. So here are places where that could leak out when you're looking at that. So, number one, an authorized employee that has access to the MES system. Let's say that that's a manufacturing site that's not in a friendly country. So somebody could walk in and just pull it straight off the MES system. That was paid by the bad guys, or an unauthorized employee could steal the CAM files. So if the manufacturing site wasn't secured, then somebody could in and pull it directly off the machine. In 3 and 4, somebody could actually hack the digital warehouse, either externally with a network intrusion, so they break through the firewall, or you could do a phishing attack, which is what happened with the drone, where somebody comes in and opens a bad email, and then their computer's taken over. And then 5, the CAM file is stolen by targeted malware, and so we're seeing a lot of ransomware and attacks like that. So all the way back at the manufacturing site. So now we've kind of identified some threats, and now we're going to kind of take them down to the next level. And so authorized employee, as you can see, we've kind of lifted them out. We've taken those kind of 5 general ones and broken it down into more specific ones. This was actually pulled off of a project we did for a customer where we were just doing an analysis like this. And so now that we've identified our threats, we're going to go through and we're going to see, okay, the impact, again, how hard will that be, or how much would that affect me? Fairly low if somebody gets a hold of this information or this occurs and it doesn't really affect us, that's not a problem. And then likelihood, if it's extremely unlikely that somebody at on a Navy ship, which is one of our projects, is going to actually maliciously modify or steal, then that's a low likelihood. And so maybe we don't need to address it, or at least not immediately. And so here we have this this graph that's kind of set up. And so let's look at what that means to actually figure out what the impact is. And so again, the impact, the definition is anything that's going to give to an undesirable outcome or negative impact represents a risk that can prevent the value creation or erode existing value. So some of the examples of this is excess cost. So if this threat occurs, it's going to cost me more to produce the product, or is it going to increase my costs on other areas? Is it going to generate revenue? And so this would be a lot in manufacturing or whatnot, where I've got to increase my QA or whatnot. Is it going to cost revenue? So am I going to start losing customers because I've lost my reputation because a counterfeit part has caused something bad? Am I going to, now the counterfeit has fled the market, and so that's going to generate, now all of a sudden I'm competing against the counterfeiters. So revenue is definitely a huge impact. Asset deterioration. So this is, hey, is my reputation destroyed, right? These parts are known to cause crashes, so we're going to start looking at other places. So it's now reduced the value of your assets, your digital assets. And then litigation exposure. Am I going to get sued? Like the part crashes, it's a Boeing part on a stamp on the part, and it gets traced all the way back. And it was something I did where I could have prevented a network intrusion. Now I can get sued. So these are some of the impacts that you have to actually consider, and put numbers to on how much we're worried about. And then you cross that with this likelihood. And I mean, this is a risk mitigation system, just like in any other type of business, in any other process that you're adding, you've got to look at what is the risk. So high, medium, low. We don't have to go too much into detail. I'm pretty sure the people on this call will understand risk assessment, but you have to actually rate it down into a number so that we can actually start doing some comparative analysis. So again, going back, we use a modified SANS, and so we use this as our severity rating. Kind of exposure versus severity are the two prospects of impact. So how exposed are we versus how severe it is? We use those two axes to come up with an overall impact rating, and then it comes down to where we have and then we combine that with our risk, and we come up with an overall. Is this a minor exposure with a minor severity all the way up to highly exposed and highly severe? And so this is kind of a peek into the actual technical details of the SANS. And so then now we have kind of what we've done, or we have a list of what we want to address and what we want to do. So our goal is we want to mitigate these problems. And so to mitigate a problem, it's anything that you're doing to either reduce your exposure or reduce your impact, reduce that likelihood. So the goal here is to reduce one or both of them if needed, and kind of fix both. So you have to actually, when you look at mitigation steps, you have to look about how does it mitigate the likelihood as well as the exposure, and how do we get both of those down when you're actually trying to fix a threat. And so here's what we've done is we've taken our 13 kind of IP things. Okay, this one we worry about revenue. So number one, just as an example, an authorized employee steals a CAM file and provides them to a competitor or rogue state. Now all of a sudden we're worried about revenue. If a rogue state gets a hold of it, that's just less sales we're going to be doing, as well as, we've got a bunch of flooded parts out that have our brand name on it, and so we could get sued over that. Or we have liability to possibly keep those parts flying. And so, we go through each of these and try and figure out the impact, and then we do the same thing with the likelihood. And so, again, looking at the top one, if an authorized employee steals it, it's not likely. We trust most of our employees. It has a huge impact. And so now that we have that graphed, we can see that we can now put bubbles on it. And so the bubble size is kind of how they fit together. The vulnerability rating and where they fit on the graph tells you, so you don't want problems that are in the upper right-hand corner, like number 4, CAM file stolen by a phishing attack, is something that you really, really don't want. And so the goal here is to start bringing mitigation strategies that start bringing those, that change those all the way so that they move to the bottom and to the left. And so here we've got some mitigation strategies that we put in for our customer, and we've mitigated. So we've moved, in some cases, all the way to the left. So the impact is extremely high still, but in that case, it wasn't cost effective to get the impact down, but we got the likelihood down to where it was nothing. So basically, we made it so that in this case, we made sure that we trusted our authorized employees, and we added an identification system onto to make sure that we fully authenticated to make sure an authorized employee was correct. And so that moved 2 over as well. And so we were able to integrate, do a further background check on authorized employees, as well as make sure that they were actual real, and we've now mitigated. Still has a huge impact if it gets out, if that happens, but now the mitigation's low. And so the goal is always to bring them down to the bottom left, but just getting them on one of the axes is actually, it can also be helpful, again, depending on how much it costs to do the mitigation. So with that, I'm just going to kind of summarize up. Your digital supply chain deserves a full evaluation, and there's companies out there such as ours that can help you do that. But before you actually just start trying to bolt on features at the end, it's very hard to do. So one of the examples I use is from the pay TV industry. That was an industry that went digital relatively quickly. And then all of a sudden they had millions of subscribers, guys like DirecTV and Dish and others in Europe. And all of a sudden they wanted to bolt on security and found out that they had to replace the set-top boxes in people's houses. So and it was not easy to just change. And it was a problem they had to address and still address today because they didn't put in the patterns at the beginning, make to make it so that it was easy to bolt on. So what I would encourage as well, not only that it needs a full evaluation, that you should start that evaluation as soon as you start implementing these supply chains, that even if you don't address those risks now, that you know what the mitigation strategies would be, and so that the bolt holes can be put on so that you can bolt it on later. And so finally, the last thing I want to leave with is define the problem and then solve it with the proper tool. And so a good example we like to use is blockchain. And so going back to our model, blockchain would be very good at preventing nothing on this chart. On an IP theft, preventing IP from being stolen, blockchain is not a good solution. Blockchain is a great solution for authenticating real parts, for making provenance, so that if you scan a part and the software spits out and says this was manufactured by such and such at a certain day and whatnot, that blockchain can definitely help in that. So it can help because it makes an immutable ledger and a good track. So it's a tool that my team uses to increase, but from preventing IP theft, blockchain isn't the right tool. And so that's kind of the last summary point I want to leave with is make sure that you go through a process like this where you come through and you say, okay, here is what we're trying to address, how we're going to mitigate it, and that mitigation is how it fixes the problem. And that's kind of the last thing that I'm going to leave you with. And so with that, I'm going to turn it back over to Jason to moderate and ask questions as needed.
All right, thanks, Joe. We'll now head into the Q&A session. If you do have any questions for Joe and haven't done so already, please type those into the chat box. I have a few questions here we can start with. So Joe, where do you see the most vulnerabilities for companies that are moving from more traditional manufacturing to implementing additive manufacturing?
So that's a really interesting question. And when we first started Identify 3D, we were very focused on additive. And what we found was additive is actually just kind of the latest wave in what we like to call digital manufacturing. What that means is manufacturing in the last 10 years is starting to fundamentally undergo a change from an analog digital world. And as that happens, all of a sudden, all the problems that, again, media and other industries that have gone through this are starting to emerge. And so when you're starting to put in digital manufacturing, so additive is the most advanced to that, right? Because there is a lot of digital control, and additive by its nature, and as it's coming on, there's always fancy, and there's a lot of controls and bells and whistles. But even more traditional manufacturing techniques like CNC, things that have been around for a while, those are going way more digital and more automated as well. And so what we're finding is exactly this, is that as the manufacturing industry as a whole moves digital, and more parts or manufacturing devices go online, and automation and MES becomes more and more complicated as parts go from very dedicated lines to very small job shots that are doing a varied amount of parts. And all of the problems that we've talked about become real, and you have IP and again, our value props are trying to address that. And there's a security issue, not only around IP and malicious modification, There's quality and repeatability. There's data feedback. There's the entire digital thread, and that's what we're trying to address. And we're doing that through education.
All right, thanks, Joe. So why is it so important to start thinking about a supply chain security during the planning phase as opposed to bolting on security to an existing supply chain?
Yeah, and you know, I touched on this a little bit in my summary, but again, in the pay TV industry, they attempted that and it just didn't work out well. So imagine that you put in digital infrastructure just to get something up and going, and in the manufacturing world, once something's going, nobody wants to touch it, but we will want to replicate it. So now all of a sudden, the more nodes you put online that are insecure, the harder it becomes to actually add security on later. Things you can do at the very beginning in the planning phase, you don't have to add security on at the beginning. That's okay. But you have to add the path to add it. So if you can say, well, this is going to be insecure right now, but if we simply add a smart card to a machine down the line, here is the path to do it, but we don't need it right now. That little exercise can save you, you know, tens, maybe even hundreds of millions of dollars down the line between redeploying, requalifying, and manufacturing is, again, one of those processes where, and supply chain is as well. Once it's in place, we want high repeatability. And so, again, you need to plan out anything like this that's going to be as this fundamental change so that things can, so they can be planned. And the goal is you want to make it so it can be bolted on later. We really want to enable that. It does take quite a bit of planning up front to do so.
All right, thanks, Joe. So that's all the questions we have for today. That will wrap up today's TRX webinar series. I would like to once again thank Joe Inkenbrandt. If you have any further questions for Joe, please reach out to him directly at joe@identify3d.com. There will be a post-webinar survey going out to all those who participated. We do really appreciate the time you take to provide American Makes feedback so we may continue to improve and strengthen the additive community. And a reminder that if you think you or your organization will be interested in sharing on the TRX webinar series, please fill out the form that follows the presentation or reach out to Tiffany Westbay or myself, Jason Thomas.